Hello and welcome to my video series C# for RPA developers. In this video we are going to learn very awesome methods of string variable type. Without further ado, let's begin. In this video we will create new variables for the results of methods because I want to demonstrate the resulting variable types of these methods. Normally you don't have to create a new variable every time you use a method, and you can use the methods one after another. I will upload this business object to my GitHub just like the business objects in my previous videos. I will include the compact versions of my code stages whenever this applies. Make sure to check out my business object afterwards because I also add comments and explanations in the code stages. First thing we are going to learn is the length property. This is not a method, this is a property. Variable types have various properties. Length property is one of the properties of string variable type. Length property basically gives us the number of characters in a string. It is very probable that you may need to check if a string is not shorter than or longer than a number of characters, or it is not empty. I have already created a text data item with the name user_reply with some initial value. Let's say in your RPA process you must check if a user reply is not empty, so I have also created another number data item and the new code stage with the name of length method example. Let's create a new input variable that takes in our user reply data item and create an output variable that will give the result of length property as a number to our data item. We simply write int user reply length result equals user reply dot length and end this line with a semicolon character. Output of the length property is an integer variable type. That's why we created an integer variable and assigned the length value to it. Don't worry about integers at this point. We will go into detail in the upcoming videos. Then we must assign the result to our output variable. Therefore, we are going to write our output variable's name and put an equals character, then write our integer variable's name user reply length result. Now, if we check and run our code, we can see that the number of characters are counted and assigned to our data item. Later in our object, we can use the decision stage to construct our logical flow like shown. If I delete the value of the text data item partially or completely and rerun the code stage, we can see the result changes with the changes I made. Next up, we have ToUpper and ToLower methods. These methods are used to turn our string value into uppercase or lowercase forms of that value respectively. I have already created a data item with the name of sentence and wrote some mixed case value to its initial value. Then I also created two data items with the names sentence lower and sentence upper. I will open my previously created blank code stage and give the sentence data item as input variable. Let's not forget to designate our output data items as well. In order to turn our sentence into its lowercase form, let's create a string variable by typing string lower result equals sentence.ToLower, opened and closed parenthesis, and end the line with a semicolon. For the uppercase form, let's write string upper result equals sentence.ToUpper, opened and closed parenthesis, and end this line with a semicolon. Result of ToLower and ToUpper methods are in the string variable type, therefore we must assign the results to a string variables whenever we are using these methods. When we compile and run our code stage, we can see that the value is the same, but all of the letters are in its uppercase form in our uppercase example and lowercase form in lowercase example respectively. I use lowercase uppercase conversions very frequently when I am to check if two strings have the same value. I usually lowercase both values I am checking and decrease the chance of making an error. Let's demonstrate this with an example. Let's say we have a data item with text type and this is the email sent by a user. Let's say our case dictates that if user email equals to the word OK, we are going to press the button X in our application. And if it isn't, we are going to press the button Y. In my code stage, I added user email message data item as input variable and user email message lower as output variable. I simply use lowercase method to standardize my comparing logic. It doesn't matter if my email body data item is mixed, all upper or lowercase, my robotic flow can decide if it is equal to the word OK or not. As you can see, my action compares the incoming value correctly for every case of input and presses the X button as long as the input is the word OK. Let's continue by mentioning the plus sign and concatenation in strings. Plus character allows you to concatenate two or more string values together. It is very simple to use. I have created two different data items named name and surname and gave them some initial values. I have also created another text data item named result. Then let's open my blank code stage named Concat example. In our code stage, we designate the name and surname data items as input variables and result data item as output of our code stage. Now we simply need to write string name surname equals name plus character, one space between double quotes, plus character, surname and the semicolon to close our line. Concatenation basically combines two or more string variables and the result of concatenation is naturally a string variable. That's why we created a string variable and assigned the result of concatenation to it. Let's check our code for errors and run the code. As you can see, plus character concatenated our variables into a single string variable. Notice that if I change the value of name and or surname data items, my result also changes. Remember our use of string.Format in the previous video? We could do the exact same thing using concatenation with the plus character, but string.Format method has some other advantages and simplify things a lot. I have copied and pasted our code in the previous video and I will duplicate the as-is code stage, but this time I am going to use plus sign concatenation instead of string.Format. Basically, I replaced the numbered curly brackets with the actual variables and used plus sign concatenation. Observe that how neat and easy it is to read string.Format compared to the plus sign concatenation. When I compile my code and run the both codes, you can see the result of both code stages are exactly the same. Next awesome method we are going to talk about is the replace method. As the name suggests, replace method finds the occurrences of a text and replaces it with the new text and assigns the resulting value to a string variable you designated. I have created a data item named sentence and gave it an initial value of some text with underscores and hyphens where some spaces should be. We are going to use replace method to replace these characters with spaces. I have also created another text data item named result and created a blank code stage named replace example. Then let's add an input variable and address its value to our sentence data item. Then let's create an output variable and assign its value to our result data item. In the code tab, we should write string result sentence equals sentence.replace open parenthesis underscore hyphen underscore characters between double quotes, a comma, space character within double quotes, close our parenthesis, and finally a semicolon to close our line. The first argument of replace method is the text that we are going to eliminate, in this case underscore hyphen underscore, and second argument is what will take the first argument's place in our result, in this case a space. After we check and run our code stage, we can see that every instance of underscore hyphen underscore characters combination is replaced with a space. If I go back to my code stage and change space value into hash and compile and run my code, now every instance of replacement characters turned into a hash. This method can be used very frequently in our processes since you may probably be using it in calculation stages in Blue Prism or assign activities in UiPath, and now we know how to use it in C#. I would also like to mention that result of the replace method is in string variable type. Therefore, we didn't have any issues with addressing the result of our method to a string variable. Sometimes we have to check if a text contains a certain subtext or not. Contains method enables us to do this. Let's see it in action with the following example. Suppose that you are obtaining product reference codes from an application, an Excel file, a web service, or an email. In your process, let's say you have to check if your product code has branch word in it or ADC, which is short for alternative distribution channel in it. I have created a text data item with the name product code and gave it a value of credit underscore branch underscore cash as initial value. I have also created a data item called isBranchFlag with the data type of flag. As you may have known, Blue Prism's flag data items are logical data items that can have a value of true or false. Result of the contains method is in Boolean variable type, and Blue Prism's flag data type basically corresponds to the Boolean variable type in C# language. We will talk about Booleans in detail in a future video. I have also created another data item called isADCFlag with the data type of flag. Our code will check the product code and set the values of these data items accordingly. Let's open my previously created blank code stage named contains example and add an input variable that takes in the product code text data item. Then let's create two output variables and assign their values to isBranchFlag data item and isADCFlag data item. In our code, we simply write bool is ADC equals product code that contains opened parenthesis, ADC between double quotes, closed parenthesis, and end our line with a semicolon. And for our branch control, we simply write bool is branch equals product code that contains open parenthesis, the word branch within double quotes, closed parenthesis, then finish our line with a semicolon. I just mentioned that the result of contains method is in boolean variable type, and we just created our first boolean variables. We wrote bool for boolean just like we wrote string for string variable initialization and int for integer variable initialization. Let us not forget to assign our newly created variables into our output variables. Now, if we check and run our code, we can see that the values of the data items are set correctly and our flow follows the correct path. Let's give another value to our product code data item as deposit underscore ADC underscore USD and rerun our code stage. Now we can observe that the value of isBranch flag data item has changed to false, where the value of isADC flag data item has changed to true. What if our product codes don't always come in uppercase and sometimes it comes mixed or lowercase? Let's give our product code data item such values and we can see that the contains method fails to detect our keywords and our process fails to follow the supposed path. It fails because contains method is case sensitive. Not to worry, we have just learned that ToLower or ToUpper methods come very handy in such comparisons and checks. Let's open our code stage and add .ToUpper method just before the contains method. By adding the ToUpper method, I made sure that whatever the product code value is, it becomes its uppercase form before evaluated by contains method. So far in the video, I have created a new variable every time I use the method, but here you can see me combining multiple methods one after another. Notice that I didn't create a new string variable just to hold the uppercase product code value. At the point where the ToUpper method ends, a new variable is kinda created on the fly with the value of product code but in its uppercase form, and contains method uses this new variable as input. You can combine methods like this in C# as long as the output input variable types match. In this case, we used ToUpper method before using contains method, but we couldn't use, let's say, length property before contains method because result of the length property is an integer variable type and we are trying to use a string method called contains on an integer variable. If I created a new string variable for the result of ToUpper method, that new variable would be reserved in memory and I could address it later in my code. We simply used our ToUpper method on the fly because it feels unnecessary to me to create a new variable for this case. When I compile and run my code stage, we can see that the code runs correctly whether the product code data item is in its uppercase form or lowercase form or mixed case form. We have covered how we can check if a string contains a certain value, but what if we wanted to check if a string variable starts with a certain value or ends with a certain value? That's where the StartsWith and EndsWith methods come into play. Basically, as the name suggests, these methods check if a string starts with or ends with a certain string value and give you a boolean value as either true or false. Let's say we have product codes in a collection that starts either with the word branch or web and ends with either GBP or USD. And let's assume our process follows a certain path according to these results. I have already created the collection with dummy values and the blank code stage. The flag data items is branch, is web, is GBP and is USD. Results of StartsWith and EndsWith methods are in Boolean variable type, therefore we need blue prisms flagged data items. Let's open our code stage and create our input and output variables. Then let's write bool is branch result equals product code dot starts with opened parenthesis, the word branch within double quotes, close parenthesis and the semicolon. Let's continue by typing bool is web result equals product code that starts with opened parenthesis, the word web within double quotes, closed parenthesis and the semicolon. With these two lines, we checked if our product code starts with the words branch or web and assigned the method results to individual freshly created boolean variables. Then let's write bool is USD result equals product code dot ends with opened parenthesis, the word USD within double quotes, closed parenthesis and the semicolon. Let's continue by writing bool is GBP result equals product code dot ends with opened parenthesis, the word GBP within double quotes, closed parenthesis and the semicolon. With these two lines, we checked if our product code ends with the words USD or GBP. I also created a text data item to see each iteration of product code, so simply I wrote each product code equals product code. Lastly, I will assign the values of my created boolean variables into the output variables of my code stage. When we compile and run our code, we can see that our code stage calculates our flag data items correctly and our process flow simply follows the correct path. Next awesome method we are going to talk about is IndexOf method. IndexOf method basically searches a subtext inside your text and gives you the position of the first instance of your subtext. If your text does not contain your subtext, it returns -1. The result of the IndexOf method is an integer variable type, just like the length property. Before we see this method in detail, we must know that positions of the characters in a string starts from 0. Normally, you will start counting positions from 1, 2, 3 and on, starting with the first character, but in C#, this positioning starts from 0. That means that the first character of a string is in the position 0, then next character is in the position 1, and this goes on until the end of our string. Therefore, the last character of our text is in the position of length of the string -1. I have created a data item called sentence and gave it an initial value I love C#. Then I created another data item called position of the word with the data type of number. What we are going to do is we are going to write a C# code stage that gives us the position of the word love in our sentence. Next up, let's open our previously created blank code stage with the name of IndexOf example and add an input variable that addresses the sentence data item. Let us not forget to create the output variable that is going to write the position of our word into our data item with number type. Next up, we need to basically type int position equals sentence.IndexOf opened parenthesis, the word love within double quotes, a closed parenthesis, and close our line with a semicolon. Next up, we must set our output variable equal to the value of position integer variable. Output of the IndexOf method is an integer value, therefore we have to create an integer value first, then assign it to our output variable. Like I said in the length property of the string variables, don't worry about integers just yet, we are going to go into more detail in the upcoming videos. When we check and run our code, we can see that position is written as 2 in the number data item. Let's check if that's true indeed. I am going to go through the positions in my sentence and I can see that the first character I is in the position 0. Then we see space character in position 1. Then we see the start of the word love in the position 2. Our code worked correctly. Let's try something else. Let's get the position of the word C#. Therefore, I am going to change the word love inside my code stage into word C#. And when we compile and run our code, we can see that the position is given as 7. We can see in this image that our word C# resides at the positions of 7. Lastly, if I go back to my code stage and change the word C# into something that does not exist in my sentence, I can see that the result position is -1. Next up, we have the Substring method. This is an awesome method that allows you to get some certain subtext from your text by designating what position you want to start with and how many characters you want to get. Let's see it in an example. Let's use our I love C# sentence from our previous subject. I want to get the 4-letter word within that sentence that starts from the position 2. Our code stage will give us the word love as a result. I have copied our previous sentence data item into our canvas. Then created another data item called subtext with text data item type. Let me open my blank code stage and add an input variable that addresses our sentence data item. Then we are going to add an output variable that writes into our subtext data item. Now let's go to the code tab and let's type string subtext result equals sentence.substring opened parenthesis. Then we are going to write our starting position, which is 2 as the first argument, then a comma, and we are going to give the length of our subtext, which is 4 for the second argument. Then we close the parenthesis and lastly finish the line with a semicolon. Now we check and run our code and we can see that the value of our data item subtext is changed to love. If I look closely to the positions in my sentence from this schema, it is clear that the 4-character long subtext that starts from the position 2 is the word love. Another way of using substring method is with a single position argument inside the parenthesis. That way substring gives a subtext that starts from the given position and gives everything until the end of the word. Let's try our example again, but this time with a single position, which is 7. My code stage will give me the subtext that starts from the beginning of the word C# and it will go until the end of our sentence. As you can see, result is the word C#. If I go back to my code stage and change the position to, let's say, 5, we can see that substring method kinda cut our sentence from the position 5 and gave us everything until the end of our sentence. I would like to mention that the result of the substring method is in string variable type. Therefore, we created a string variable for the result of substring method. You can assign the output of substring method to a string variable just like we did here, or combine substring method with other methods. You can combine the methods IndexOf and Substring to create great implementations for yourself. Our next video will be a case study on this topic. Next simple method we should talk about is the ToString method. As we mentioned in our previous lecture, there are a number of variable types and some of them can be easily expressed as a text. For example, a number variable can be also written as a string variable. Same thing can be done for booleans or datetime variables too. Let's see it with an example. It is highly probable that in your process you may be required to create a sentence that is formed using a date, a whole number, or a number with fractions. You will probably attempt to use the plus sign concatenation in your code stage. Remember that the plus sign concatenation requires all of the variables to be string variables. And you may get a compiler error if you attempt to concatenate, let's say, an integer variable with a string variable. That's where toString conversion comes to our help. You should simply convert your integer variable into string before using it in concatenation. I have created a data item named today's date and gave it a date value. Later I created a number data item with the name of grade and gave it a value. I have also created another data item with the flag data type and gave it a value of true as initial value. Then created a text data item named result sentence. Let's open our blank code stage and add our 3 data items as input variables, which are all in different variable types. Let's add our output variable and address it to our text data item named result sentence. We are going to convert all these variables in different variable types into strings and concatenate all of them in a single string variable. Let's convert our datetime variable by typing string date str equals today's date dot toString opened and closed parentheses and close our line with a semicolon. Let's convert our boolean variable by typing string flag str equals pass status dot toString opened and closed parentheses and close our line with a semicolon. We can do the conversion for our grade variable similarly by typing string grade str equals grade dot toString opened and closed parentheses and close our line with a semicolon. At this point, we converted our 3 variables, each of them in different data types, into string variables. Then let's construct our sentence with plus sign concatenation. Now if we check and run our code, we can see that all of the variables are converted into string form of themselves and concatenated into a sentence successfully. ToString method is used all the time, especially when accessing the elements of a data table or formatting a number with decimal places and thousand separators, or trying to write a datetime variable in the form of your preference, namely day/month/year or month/day/year, a space day of the week. We haven't used any arguments inside our ToString method, but we could use some formatting arguments to change our outcome. I am going to add some formatting values inside my ToString method to demonstrate. As you can see, the way we convert our number and datetime variables can be configured by giving some formatting arguments into ToString method. Next method we are going to talk about is the trim method, and two other variants of it named TrimStart and TrimEnd. Trim basically helps us get rid of the empty spaces like new lines or spaces. Those characters are called white spaces in C#. It is very probable that you may get new lines or spaces in a string value when you obtain it from an application, an email, or a file. In that case, you can use trim method to simply delete those characters from the end, beginning, or both end and beginning of a string. You should be very careful when checking if two string variables have the same value, where one of the values could have a space at the end of it or beginning of it. In that comparison, C# will treat those variables as if they are completely different words. The distinguish between trim, TrimStart, and TrimEnd is basically trim deletes white spaces from both start and end of a string. TrimStart only deletes the white spaces at the start of a string, and TrimEnd deletes only the white spaces at the end of a string. Let's see it with an example. I have created a text data item with a value that starts and ends with bunch of space and new line white space characters. Then created three different data items for each version of the trim methods. Let's open our blank code stage and designate our data items as input and output variables. I am going to use TrimStart, TrimEnd, and trim methods to show you the results. The variable TrimStart example will contain the result that does not have white spaces at the beginning. Then let's write string TrimStart value equals name of our variable dot TrimStart, opened and closed parenthesis, and end our line with a semicolon. The variable TrimEnd example will contain the result that does not have white spaces at the end. Then let's write string TrimEnd value equals name of our variable dot TrimEnd, opened and closed parenthesis, and end our line with a semicolon. The variable fullTrim example will contain the result that does not have white spaces at the end or beginning. Then let's write string trimFull value equals name of our variable dot trim, opened and closed parenthesis, and end our line with a semicolon. If we compile and run our code, we can see that TrimStart method only eliminated the white spaces at the beginning of our value, TrimEnd method only eliminated white spaces at the end of our value, and finally trim method eliminated white space characters at the beginning and end of our value. That's it for this video. Our next video will be a case study for you to implement and practice what we have learned so far. If you have any questions, ask me in the comments or email me. Thank you for watching. See you in the next video. Take care.